Okay, I'm going to show you how I would solve problem number 3 here, which was in the type 3 problems for projectile motion. Kira wishes to serve a volleyball into the top row of the bleachers, holding the ball at a height of 0.75 meters at ground and hitting at a perfect 45-degree angle. How hard does she have to hit the ball to launch it into the bleachers 5.5 meters high and 20 meters away? So what we're going to do first is assign everything a variable so that we know which equations to use and how we're going to start this problem. Okay? Okay. Here we have the basic situation. We have Kira standing here. She is 0.75 meters high. Alright, that's how high she launches the volleyball. The volleyball is inclined at an angle of 45 degrees, and the volleyball is going to go like that. She wants the ball to land in the bleachers, and the bleachers are, well, we want the top of the bleachers then to be how high? We want them to be 5.50 meters high. The problem with this is right away you're going to see that you have no velocity along the what I would call the muzzle velocity. We have nothing to figure out how fast this is going. So I'm going to assign this the value v. Okay? Well, we know right away that v sub x is equal to v times the cosine of 45. We also know v sub y is equal to v sine of 45. So these are the v's that I'm talking about. This is what I don't know.
It's now just a little after 12:35. Your next session starts at 12:45, so please make your way to your next session. Also, please make sure you
I'll just wait for this interruption
so that you know when your mandatory session is scheduled for. That's different for everyone, so check when you need to attend your mandatory sessions, and please make your way to your next session.
Okay, in the horizontal, we can write basically one equation. We know that x is equal to v sub x times the time. In the vertical, we're going to set up that one equation that you've learned to love, the quadratic equation. So in the vertical, we have this equation, y equals y naught plus v sub y times t plus, or minus really, minus 1/2 gt squared. Okay, let's substitute in some information. We know very little about, oh, we do know. We know that the bleachers are 20 meters away. So I forgot to write that in. So we know that x is 20. I'm going to leave the units out. The v sub x is v cosine 45. I just made this substitution times time. Y, this is how high she needs to get, so that's 5.5 meters. Again, I'm leaving the units out. Y sub naught is the initial height of the ball, which is 0.75 meters, plus, here I make this substitution, v sub y is v sine 45. I'm going to run out of room here. Minus, I'm just going to make a real quick substitution. We all know that 1/2 g is 4.9, so I'm going to call that minus 4.9 t squared. I forgot t. Okay, what do we see here? We see that t is itself a variable, And if I take this t, and I could solve this entire equation for t, and that's what I'm going to have in my equation here. Now look at this. I'm going to solve this for t. So I get 20. Okay, everybody knows the cosine of 45 is 0.707. So I'm going to call this v 0.707t. So when I solve this for v, I get 20 over 0.707t, which is, now this is not v sub x, this is just v. divided by 0.707, 28.29. And that's all over t. I'm going to substitute this in for v. Okay? So this becomes 5.5 equals 0.75 plus 28.29 over t times the sine of 45, 0.707 t minus 4.9 t squared. Okay, I'm going to simplify this term now. You can see the t's cancel, and so I'm becoming, let's see, 5.5. I'm going to bring this to the other side. I'm going to simplify this, 28.29 times 0.707, that's 20. The t's have canceled, minus 4.9 t squared. Therefore, I have this term, 5.5 minus 0.75, or 4.75, equals 20 minus 4.9 t squared. I bring the 20 over to the other side. 4.75 minus 20, that's equal to negative 15.25, equals negative 4.9 t squared. Divide both sides by negative 4.9. I get t squared is equal to .11. Therefore, t is equal to .176 seconds. Well, we haven't solved the problem, but we have figured out that the t is 1.76 seconds. If we know that t is 1.76 seconds, let's go 1.76. Let's go back to this equation. We can get v, and that's what we're asked to solve for. So v is equal to 28.29 divided by 1.76 meters per meters. So this becomes 28.29 equals 16.036 meters per second. Velocity equals 16.0 meters per second. And that is how I would solve a problem like that, remembering that we had to do these substitutions.